Hey guys, welcome back to GCSE Revision for Trigonometry. This is the second problem here. It's 2D problem. It's about basic trigonometry. So make sure you watch all the video dedicated to explanations. So pause the video, try to do by your own, and here is my explanation. So you have the letter 5 meters in length that rests against the vertical wall and reach 4 meters up from the ground level. Okay, that's the right time to draw what we have. So let's say that's the ground level. It's right there. And we have, let's say we have the wall. It's a vertical one. It's right there. This is the wall. And here is the letter. So I'll use green color for that, and let's say it's leaned to the wall in this way. Okay, all right, so we've got everything. So that's the letter that lean against the wall. What we have, letter 5 meters, so we have that length, which is 5 meters, and we also have the understanding that it reached 4 meters up from the ground level. If this is the ground, so we have 4 meters that side, that's vertical side. So basically up to the reaching point. Okay, what we need to find the angle that letter makes with the horizontal ground. Where is this level? Where is this angle? That's the angle of elevation. So just remember what the elevation angle is the angle between your inclined object, inclined side. So probably it might be a line of sight if some person watching somewhere or trying to have a look at the distant star, and horizontal, okay, or horizontal level. In this case, it's pretty obvious that this angle is right there. So we need to find that angle. What we're going to use? We're going to use Pythagoras. The wall is perpendicular to the ground. So here is vertical wall. Yeah, that's actually fact tells us that it's vertical. And we apply Trig's ratio. So which ratio? We have two sides and we have the angle. Definitely trigonometry. And what about how to connect them? We have opposite sides, which is 4. And we have height, which is 5. So we use sine rule. So opposite side is height times sine of angle theta. From where we can express sine theta, or first, if you want, we can plug the values. So opposite is 4 will be equal to 5 times sine theta. From where we can figure out that sine theta is going to be a ratio 4 to 5. So make sure you correctly did it, because otherwise your sign will be more than 1. So it cannot exceed 1 in any circumstance. It cannot exceed. So it's less than 1. So that fraction is proper 1. So the test is passed. So tested and it's okay. So we put a tick and we use theta angle as inverse function of 4 or 5. So make sure you can find it on calculator. So you need to use sine minus 1 of the fraction 4 over 5. And it will give you 53.13 degrees to dp. Alright, that's the answer to the first one. So I'm going to highlight and say, okay, that's theta equals to 53.13 degrees, 2 decimal place. Okay, so we've done the first one, and let's go next. So the next point is the distance from the foot of the ladder to the wall. So where is that distance? I marked with red. Distance from the foot of the wall to the ladder is right there. It's going to be the line or line segment parallel to the ground. From where we can find that. Okay, so actually there are several ways you can apply a trig ratio. If you solve that using trigonometry, solution is going to be, so let's mark as x. In this case is adjacent side to the angle, and because you calculated angle, you can easily figure out using tan ratio. For example, if you use tan ratio, it's going to be opposite to adjacent, so 4 to x is going to be tangent of the angle theta that you found. So plug value here, from where you can figure out x. If you want to connect through hype, so you can write let's say cos rule, right? So x is going to be hype, which is 5 times cos theta, and again you can calculate that. If you want to connect through the opposite side, you will use sine. So in this case, no, actually that's it. Yeah, because you're looking for x. But you can also use Pythagoras. So in this case, Pythagoras is much more applicable because angle theta is not like, it's not an exact value. So it's rounded to 2 decimal places, so you'll have errors probably. So that's why I encourage you to use Pythagoras. It's pretty easy. It depends on, you know, how well you with trig functions. If it's good, so you can use both ratios or Pythagoras straight away. So for Pythagoras, we need to have hype squared equals opposite squared plus adjacent. So I'll just write in numbers. So 5 squared is going to be x squared plus 4 squared. Okay, from where x is going to be square root of 25 and minus 16, which is 9. So from where x is 3 meters in that case. So if you want to check or compare, let's take any one. So let's take tangent rule, from where we can figure out x. So you just simply use, this is basically proportion. You can swap x and tangent. So you swap that and you just have that 4 over 10 of the angle 53.13 degrees. So let's just compare what we have here. We've got 4 over 10 of 53.13. And we've got 3 and 4 zeros in the end. So actually to 2 decimal place we have the same answer. So 3 meters. Alright, so as you can see, you can be really fluent there and much more. So tricks along with Pythagoras give you lots of flexibility. So that was the answer for part B. Make sure you have the same 3 meters, and that's it. That was pretty easy. I hope for you guys because it's actually basics.